Hello, my name is Santiago Moreno, and welcome to 6.6, 6.6, applying properties of definite integrals. Today we're just going to be applying the properties of the definite integrals. It's kind of simple. Today, we're just going to start by doing this. So we learned before how to kind of read this. You start at this number, basically. If you want to see the simple version, you start at this number, you go to 12 with the number, and you just see the area here. Kind of simple. So we start at 0, we go from 0 to 0 here, this would be 2 pi, from 0 to 12, this would be 5, and this would be 4, because you do this, 1/2 pi, this would be 1, 1, 2, 1, right? Yeah. No, 1.5, 1.5, yeah. This would be 5, because this is 1.5, this is 1.5, this is 0.5, and this is 2, so it'd be 1.5 times 0.5, 1.5 times 2, plus 2, is it? No. 2, 2, and 1, actually. Never mind. This would be right here, this would be 2, this would be 2, this would be 2, this is 1, 2, 2, 1, this is 5, this is 2 pi, and this would be 4, because 1, this would be 1, this would be 2, and the remaining would here be 1. So 1 to 1, this would be 4. So here we would write, it would be 2 pi plus 5, plus 5, minus 4, because 4 is in the negative. However, if we go from 12 to 0, we would start at 4, so we have 4 minus 5, because it would be in the opposite direction of where we start, minus 5, minus 2 pi. And that's just to understand that, it depends how you look at it, sorry. Depending on how you look at the, sorry, my thing messed up. Depending how you look at the graph, you can have several different versions of the same thing, or what would look like. So properties of definite integrals. Let's read that real quick. Equivalent limits. So this would be the integral of a to a f of x d of x is just 0 because it's at the same point. Okay. The reversal of limits is integral a to b f of x d of x is equal to kind of just the negative. It's the negative of of kind of like the opposite. Negative of integral b a f of x d of x. It's just like the opposite. It's the reverse. You can say it's not. It's negative. It's negative instead of positive, and it's b to a instead of a to b. Yeah, that makes sense. It's easy. That's what it's called. The reversal of limits. Multiply by constant. K is equal to constant. That would just be k times integral of b to a. B to a. No, sorry, that's not an f. Integral b a f of x times d of x. And that's the same thing. You're just moving the k over here. Adjacent intervals. That would just be integral b of a, because they're so close to each other, b of a, sorry, b of a, b and a, of f of x, d of x. Since they're adjacent to each other, you just use the one in between, which was just this. And that works for us. And then addition would be, here we have integral b of a of f of x plus g of x. That would be the same thing as integral b of a of f of x. Sorry, that's not b of a of f of x times d of x plus integral b of a of g of x times d of x. And the same thing would go for the subtraction one, except it would be opposite. You would be subtracting the g of x. So it would be integral b of a of f of x times d of x minus integral b of a of g of x times d of x. This is just kind of understanding the properties of definite integrals. Is just so we can to simplify our lives and not have to go and use the full way and having to continuously do tedious work, and this way we can just get to the answer quicker instead of doing the interval. For example, for this very first one, instead of doing the integral of a to a of f of x d of x, we just know instantly that it's 0 of any value, of a constant value. And yeah, that's basically everything for 6.6, and I'll see you in the next one.